Hi friends, welcome to the session. Today we are trying to understand the importance of a new library called as polars as compared to pandas, right? So we all are too much addicted to using pandas. What about a new library called as polars, right? Yes, it exists since a long time, but are we even bothered to learn about it? If not, it's high time that we learn about it. So what is polars? Well, polars is a lightning fast library specifically created for working with data frames. It uses all the cores of your system and therefore it is blazingly fast. It's written in Rust to give you C++ type of speed. Let's go through it. So if you want to get into the documentation, as you can see, friends, that's the link to get into the documentation. Click on it. Notebook will be there in my GitHub profile, and you will see all the implementations which I'll be doing right now available in the documentation. So yes, as you can see over here, it's a blazingly fast library written in Rust. So obviously there is no runtime overhead. C++ type of performance providing lightning fast data frame. Let's directly get into the implementation notebook. You can study it at your convenience, right? So if you want to install it, pip install polars, or you can open up your Anaconda prompt if you're using a Windows system. And yep, just paste this particular code and that's it. There you go. It will get installed and you can feel free to execute this notebook and see the speed. So I import polars as PL, and please observe the syntax, right? It's a little bit different from pandas, but nonetheless quite same. We created a series. You can see this is how it gets printed. It's of the integer data type requiring 64 bytes of memory. And then we create a data frame. As you can see from here that we are creating a polar data frame. Column 1 called as integer. You see over here, column 2 called as date. Column 3 called as float. You can give any names over here. And whatever values you want, they are coming over here, as you can see over here very clearly. Super. For printing, you have the print data frame, gets printed in a tabular format, just like how it comes from the SQL data frame. I look at the head of the data frame. Yes, quite similar to pandas. Therefore, it's high time that we transition to this. Tail, last 3 records. You also see the data types mentioned over here, right? That is one of the cool part, right? You know, no need to fire the .in for any other function. And I look at the sample, any 2 rows, right? Then describe, you see over here, it says what is the shape of the data frame. It also gives exactly the same functionalities given by the pandas very clearly, right? So transition from pandas to polars should be simpler for you, right? We cannot give reasons that, oh no, we are quite accustomed to pandas and I am not ready for this change. Okay, then I created a polar data frame from the scratch, as you can see, and let's try to do few operations on it. So creation of the data frame, it's very similar to our Panda. So column NRS, names, random groups you see over here, and these all are the values which are given in the form of a list. You see, head we have already seen. Okay, cool. So I need not have the cell. Now, what am I saying? Well, if you observe over here, let me execute the cell and yep, I say that from this data frame, right? This data frame is called as DF. From this data frame, I want you to select, okay, sum of NRS columns. So it's going to be this plus this plus this plus this plus this, and null is going to be obviously what? Not counted, right? So sum will be 5, 6, 7, 8, 9, 10, 11. So we are expecting a value 11 as the sum. Remember it. Then the names column, I want it to be sorted. Okay, so it's going to be sorting in the ascending order. And if you sort in the ascending order, then let's see what happens. Then I have the names column dot first function, and alias name will be first name. So you can see the new column is named as first name. You can see it over here. And I want the mean of the NRS column. So let's see over here. All the values are 11. Names you can see are sorted. Yes, N null is not going to be sorted. Then E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S. First name Foo came over here. Cool. And yes, the data types and the mean has come over here. Then I say, let's try the sum of the NRS column and the random over here in place. So you can see over here, I have the sum and the random values in the count you see over here. Going out in this data frame, which is my DF, I am saying that in my column, right? So let me first show you DF dot head. So in this data frame, I want to know where all NRS is greater than 2. Probably these 3 places. No, don't count null. This is the place. This is the place. NRS greater than 2. So I am basically filtering it out and let's see whether we get the results. 1, 2, 3. You get this. Simple. Let's try a very basic group by operation on this data frame. So I'm grouping it by the groups column, which you have over here. And aggregate function which I'm applying is sum on the NRS column, then a random column to be applied with the count function. And after that random column, I'm trying to filter out where the names are not null, summing it up total. And then this calls where I'm planning to reverse it. Let's see the interesting results. Right, I've kept it very short and simple. So you can clearly see over here how the things are, right? So if you see sum of NRS, yep, you have that over here. Then after that, I have the filtered out value in the names column and they are sorted in the descending order. Yep. And lastly, one quick demonstration about pandas and polars. Imported it once again to show you. Oh, sorry, I don't have a watch, right? How fast they are. Okay. So there was a dependency. I had to install this Arrow because I'm reading a Paraquet file. So I am reading it. It's a huge data frame. I will show you the shape of that. 336,000, right? Okay. Then I am simply reading that file and doing a group by operation using the Panda syntax. PD, दिख रहा है ना PD? बढ़िया है.
One eternity later.
Yes, 50.1 milliseconds. And here I'm trying it with polar 18. अरे 18 कहाँ पे है? 50 कहाँ पे है? You're understanding why am I asking you to have a transition from this library to that? Okay, if you can't have transition, at least be aware of the library and ensure that you are using it in time constraint environment, resource constraint environment. That's it for the day. Thank you very much. Happy learning. See you all. Bye-bye.